If you think about this aircraft flying for 5, 6, 7 decades, the pilots that pilot this haven't probably even been born yet.
This is the Tempest. Or is it?
This is just one potential concept, what it might look like. It's to describe a vision more than anything else. It's to put something tangible in people's minds as to what the Tempest future fighter might look like. That's undefined yet. This might be a smaller aircraft, it might be a bigger aircraft, it might have loyal wingmen of unmanned air vehicles alongside it whenever it's sent into theatre. That we don't fully know what it will look like, but we know that in 2040 onwards, we will have an emerging and enhancing threat that we need to develop technologies and capabilities to really overcome. So the pilot might be flying this aircraft, which will be the central aircraft, and then there might be smaller, less costly unmanned air vehicles flying alongside him, which could act as decoys. He'll be able to fly those, but they'll be much smaller, less capable aircraft, and this will be the centre capability which he will fly.
Since 2003, the Typhoon has been at the forefront of RAF operations. But in 15 years' time, the Tempest will take over and bring with it a whole new generation of weapons.
The environment's changing, and the threat's changing, and therefore we are looking at laser-directed energy weapons. They're around and about on the ships. There's other countries invested in them as well. But what we are taking a role on Tempest with our partners is to actually try and integrate them onto an air platform. So this would be the first fast jet with a laser-directed energy weapon on it. The threat of the future, and the threat of now actually, is very low-cost, cheap weapons that are sort of offensive weapons to us. So therefore, it's a great defensive mechanism as well for a future air platform.
And what can it do that a missile can't?
It's incredibly accurate. The details of which I can't say, but it can be incredibly accurate.
We're looking at everything from within flight systems areas, we're looking at battery technologies and using a lot less hydraulics. In the cockpit, we're looking at using augmented reality and virtual reality and trying to take a lot of the hardware away from that cockpit environment, and that serves two purposes. It allows very quick, upgradable software approaches, and it takes away weight and it takes away cost, and it allows the pilot to do a lot more. And that might be that he might be engaged with the unmanned aircraft that fly alongside this in a system of systems, and we're working on strategies to understand how there is a manned-unmanned teaming arrangement that says when does the pilot take control of an unmanned air vehicle and when does it let it make its own decision. We will always want a pilot in the centre of that, and we will always want to make sure that he's in control. However, we're looking at autonomous systems that can switch on and switch off different activities for the pilot, and we're using things like psychophysiological monitoring of the pilot. So we're trying to determine, without the pilot needing to tell us from his biometrics, how might he be becoming overloaded, and at that point we might take activities away from him, and that's a real area of focus, because you need to make sure that there's a real robust approach to that. We're obviously exploring stealth capabilities on the aircraft, flexible payload bays, because the future of weapons could look very different to what they look like today. So we're looking at options to have flexible payload bays, have different missiles all contained within it. We've got to do this in timescales that support Typhoon going out of service, which means that we've got to do this in half the time. So when we get to a key milestone, which is 2025, where we go through a final investment decision, we'll have 10 years to get this into service. And that's a real challenge. And we've got as the whole industry is probably an ageing demographic in engineering, that you need to transfer the capabilities into the younger generation. So we'll do that, but another part of this is making sure that younger generation is also bringing new ideas and new ways of working, because we're well aware that if we do the same things we've always done, we're not going to do this in half the time and significant cost reduction. If you think about this aircraft flying for 5, 6, 7 decades, the pilots that pilot this haven't probably even been born yet. Some of them may have even just started school, but that's as far as it will go, because this will go into service in 2035 and will probably fly out well into the 2070, 2080s.
For BAE Systems and the other manufacturers working on this project, they understand just how important the Tempest is to the future of British defence.
It feels like a once-in-a-generation opportunity, and the whole team know that. The whole team know that they're working on something that is probably unprecedented. The challenges that we're trying to overcome are unprecedented, but it's really exciting, and the team feel a sense of responsibility. Yes, it's right at the cutting edge and we're trying to push it as fast as we can, but we also know there's a lot of technology that we don't even fully understand yet. So we're building it to try and future-proof it so that it's easily upgradable.
If you enjoyed this video, don't forget to like and subscribe to our channel.